Hi, in this video I'm going to explain further this concept of rational functions, and I'm going to start out by reusing the ones we have used in previous videos to explain this topic. I'm going to start with the simplest one, which is this 1 over x minus 2, the simplest type, and I'm going to check out the similarities with this other one when we have multiple factors. In this case we have two factors in the denominator, so I'm going to start out here by noticing the similarities here. For starting, you can see there is a horizontal asymptote here in y equal to 0, and it happens just the same with this one with two factors in the denominator. The thing is, if there is nothing adding up or subtracting up this function, any of those, then the function will not displace upwards or downwards. So now let's see some of the similarities here. We have that this function 1 over x minus t has only one vertical asymptote. This vertical asymptote, it's x equal to 2. We got that this vertical asymptote just by taking what's the denominator in here, dx minus 2, and we equalize it to 0, and then we solve for x. So we got that x is equal to 2, and then that's the way we found these vertical asymptotes. So we do something pretty much the same thing with this type. We have two factors on the denominator. We do the same with, but only with each factor. So that's how we got that x minus 2 it's equal to 0, and x plus 2 it's equal to 0. Then we got the asymptotes will be x equal to 2 and x equal to negative 2, which are in here. This one, it's in here the negative 2, and it's in here the positive 2. I'm going just to sign it out. X equal to negative 2, and here we have x equal to 2. Now, the way there's something different, particular for this type, the second f of x. We have in here this in here we have a y-interception that in this case from the previous one, the first one, 1 over x minus 2, we do not have it. The way we find this y-interception, it's by substituting to 0, doing f of 0 for this f of x, the second one. So we get that 0 minus 2 times 0 plus 2. Oh, this is really ugly, the way I'm writing. 0 plus 2, we close this one, and we just have to solve this out. So this y-interception will be 1 over negative 2 times a 2. So in other words, this interception will be on negative 1/4, which is this point we have here. It's the y-interception. Now I'm going to add something new. I'm going to display another function, which will be a function that will be a bit different than the second one, than this one. I'm going to add something in the denominator, which is in the above part, the superior part of the rational. So here it is, this function. We have now this x minus 1 on the denominator. So it changes the way the graph behaves. You can see it in here. It's not the same. It changes from the previous one, from this one. Yet we can start out by signing the similarities. We can see just, for starting, we can notice that there is a horizontal asymptote, or something really close to horizontal asymptote, because we have here a big difference. We have this point that it's crossing out this horizontal asymptote. So we could say that this horizontal asymptote works as such outside of the vertical asymptotes. I think will be clearer in the future, but I'm going to start by signing out this y equal to 0 to be the horizontal asymptote. I'm just going to write I'm going to write it in here as I'm going to sign it out like this, just to notice that there is a peculiarity. There is something here. There is a way. There is a point that this horizontal asymptote it's not behaving as such. Okay, let's move to something else. I'm going to start here by we have here in this case two vertical asymptotes that are just the same as the previous case. Actually, we found it. The way we locate them is just exactly the same. We equalize to 0 each of the factors, the x minus 2 factor, the first one, and then the second one, and we got that x equal to -2 and x equal to, I'm sorry, this is the other one was the positive 2, and here is x equal to -2, and that's how we got these two vertical asymptotes. I'm going to write it in here, this x equal to -2, and here we got the x equal to 2. Now let's see, we have a y interception in here as well, and I'm going to, the way would you find the y interception is actually very similar to what we did before. We have to evaluate the function, which is this function with a value of 0, and I'm going to do it in here. Would be 0 minus 2 times 0 plus 2, and on the denominator we have 0 plus 1. Actually, I'm pretty sure you will notice we get to the same result. That's just on purpose. Just by solving this out, we get that it's -1/4. So we got this is this point, which is the y-interception. But now let's see what's different here. We got this other point, which is, I'm going to sign it here with blue. This point here, this is a x-interception. It's crossing out the x-axis, and I'm pretty sure you can some of you may have inferred the way you can locate that point, which is using this factor in the denominator. You take this one and you do something very similar to what you did with the vertical asymptote. So you start at about x minus 1 and you equalize it to 0, and x is equal to -1, and that is this point that you have in here, x equal to -1. It's the x-interception, and I'm going to write just here the y-interception, which is, I'm going to actually I think it would be better if I write this as coordinates. So this is the -1, 0, and the other one it's the 0, -1/4. This point in red, it's drawn here, and I'm actually going to draw as well here the 0, -1/4, which is this y-interception. And well, and here there's something other difference. You may see in the previous one, this function f of x with two factors in the denominator, it's a very clean pattern the way you draw this graph. You start over here by drawing something like this, and then you jump down and do like an inverted U, and then you jump to the next level. So it's very clean that you start here, then you jump here, and then you draw here. It's very clean. But however, in these cases, it's not so clean in a way to say it. You can see that you start in here, then you jump here, but you cross out the x-axis, and then you jump to the third section here. So it's kind of confusing the first time you see it, but I'm pretty sure that you will just begin realizing the pattern here. There's a very clean pattern as well. Now I'm going to move to another graph. I'm going to add another one on the right, so I'm going to scroll here a bit to the right. Yes, And I'm going to add this one. Boom, you have here a new factor on the denominator, which is this x minus 6 in over here. And so you can see the graph behaves in such a way like that you can infer a few things. I'm going to start by signing out the similarities. There is as well something like a horizontal asymptote, except for the fact that you are crossing out the x-axis around here. I'm pretty sure you know by now which point is in here, the x-interception, but I'm going to start out by this the horizontal asymptote. Again, I'm going to mark it here because it's not exactly a horizontal asymptote, but it's very close to it. We have as well vertical asymptotes, and I'm pretty sure we can just we would have to find the vertical asymptote. We have to repeat the process that we have done before with each of the factors in the denominator. Basically, you have to equalize them to 0. I'm not going to do the whole steps. I'm just going to sign out here. This is the x negative 2. Oh no, I think I better do everything out. I'll do it quickly. Will be here the x x plus 2 is equal to 0. Here is the x minus 2 equal to 0, and here is the x minus 6 equal to 0. So this we got the three vertical asymptotes. It's x equal to negative 2, x equal to 2, and x equal to 6. And these are the x equal to negative 2. This is the x equal to 2, and we got here the x equal to 6, and those are our three vertical asymptotes. Oh, now let's see. We have this is it's pretty tough to watch it, but we have here a y-interception, and I'm pretty sure you can just infer how we're going to find it. And we're going to do pretty much the same thing. We're going to evaluate for 0 here, and I'm going to substitute all the x's by 0. I'm going to solve it out. 0 minus 6. Again, like in the previous cases, you normally get something really close to 0, but not exactly. So solving this out will be a positive number, which will be 1 over 24. Yes. So that will be our y-interception. I'm going to write it in red here. It will be 0, 1 over 24. This is a y-interception. Now I'm going to move to get the x-interception, which I'm quite sure you notice how we're going to do it. We're going to take what's in the denominator. We're going to repeat the process from the previous example. It will be x plus 1 equal to 0, and then we got that x is equal to negative 1, and that is our x-interception, which is over here. And that will be the point negative 1, 0. There it is. Whew. Well, now we have to move to another case. I'm going to add another graph here. Will be this one. I'm going to scroll a bit. There it is. Now I'm quite sure you've been noticing the patterns out through so far. We have the same horizontal asymptote, or kind of a horizontal asymptote, because we are crossing out now in 2 points. We're crossing out in here, and we're crossing out in here. I'm just going to I'm going to repeat these steps from the previous one. I'm just going to do it a bit quicker. Here we have a asymptote, which is I'm actually going to sign it directly on the graph. We isolate each of the three factors we got in the denominator. That's the way we got our vertical asymptotes. This is x equal to negative 2. This one, the next on the right, is equal to x equal to 2. Here is our x equal to 6. And well, now the only thing that's different is that we're crossing out the x-axis in 2 points. I'm actually going to jump directly to this. And to find out the x-interceptions, we're going to take each of the factors in the denominator and equalize them to 0. Basically what's in here, what we have done before. So the x plus 1 equal to 0 and x equal to negative 1. then here x minus 4 is equal to 0 and x equal to 4. Those are our two x interceptions, which are in here. Will be this is a point 4 comma 0, and we got this other point, which is the -1 comma 0. Now the only thing missing here would be to find the y-interception, but I'm pretty sure you're very familiar with this process. It's f of 0. We have to evaluate the function for 0, and we got that it's 0 plus 1 times 0 minus 4. We'll get here it's over 0 plus 2 times 0 minus 2 times 0 minus 6. Oops, I'm running out of space here. Well, this will be equal to, would be -4 over 24. In here, -4 over 24, we can get the fourth of it would be -1 over 6. So, well, this is basically the point. I'm going to sign it out. I'm going to locate it here in the graph, which is somewhere around here, and it will be on the 0 comma -1 over 6. That's my y-interception. Well, I think this is just the first video to start warming up with this topic, getting deeper into the reciprocal, the rational functions. And now that we know the process to find all the meaningful points and asymptotes of these rational expressions, these rational functions, let's move to how can we make it more in a very intuitive way how to graph this out.